Okay, if we take a look here at sample problem number 1, first thing we want to do is we want to factor out all the denominators so that we get a clear look at what the least common denominator would be. And if we look here, we can clearly see that x plus 1 and x plus 2 is our least common denominator. So I'm going to want to multiply that those terms to both sides of the equation. Okay, now I've set this up, so what's technically going to happen here is I'm going to take this entire expression and I'm going to multiply it. I've got to distribute it across this addition, and then of course this is just going to the 1. And so when you do that, we're going to create a situation where we have some canceling out. So I'm going to go ahead and do that next. Okay, and you can see here I've done the distribution. I'm not actually multiplying all this together because the polynomials would get very confusing. By leaving all of this in factored form all the way through to the end, it makes this simplification at the end much easier. So now we'll go ahead and cancel out anything that can be canceled out within each particular part of this. And the desired effect, obviously, is to get all of the individual parts of the denominators canceled out. So we're left with something simple like this. And so now we have a very straightforward algebraic equation that you can just simply work from here. So go ahead at this point and you're just going to distribute everything, combine like terms, and then solve for the missing x at the very end. So I'll go ahead and work that forward. And now you can see here we get to a simple quadratic equation after we combine all the like terms. And a quick factoring and use of zero product property will give us the values for x. So because we're dealing with a perfect squared trinomial, we can see we get two values of x equals -1, so we have a little multiplicity going on here. Now, here's the thing. Since we introduced since we introduced, and we technically did introduce a quadratic expression, but since we introduced any algebraic expression to the equation through clearing the least common denominator, we have to check to make sure that our final solution works, because it could be extraneous. So we definitely need to plug this back into the very original equation to verify that -1 is actually going to work. So we'll go ahead and check that. And a quick setup of this, you could punch all this into your calculator if you felt like you needed to, but you can see really quickly here that you're going to end up with a situation where you have 0 in the denominator of one part of this, and if any part of this is undefined, then you have an issue with the solution. So in this case, since this is undefined, we have no solution for the answer, so the -1s aren't going to work there. Alright, and so that is your first example of solving a rational equation.